Hey everybody, thank you for clicking on my video. I really appreciate it. If you haven't subscribed, please do. So for those that are new, what I do is I take old electronic projects from old electronic magazines and I bring them to life, build them from scratch, and I test them afterwards and I show you all this. That's what I do. Hopefully that interests you. And if you think I'm a genius, I'm far from that. In fact, I might even be a little bit almost on the idiot side, but I try my best. I'm a technician, probably is a good definition of me. But I'm passionate about building these projects. I really, really like it. In fact, I learn a lot from the comments that are left below the video. So thank you for everybody commenting. I take all your advice and I learn from it and I keep it in my head and hopefully I'll remember it for next time. So what we're going to do today is we're going to look at a new magazine that I never knew about. It's an old magazine, but I never knew about it. It's called Maplin or Maplin. I'm going to go with Maplin. And we're going to build a capacitance meter. But if anybody out there has built projects from Maplin, leave a comment below and let me know what you built. I'd be really interested. Maybe I can build it because I've got all the issues of the magazine. And one other question, if there's anybody watching this video from India, let me know what your magazines were. I'd like to see if I could get some of those issues and build some projects from them. Leave a comment below. I'd really appreciate it. So yeah, we're going to build a capacitance meter, right? So who doesn't need one of those? I probably have about 8 of them. But we're going to go to June 1987. And it's a digital capacitance meter, which is nice, 7-segment display. And I'm showing you the inside of the author's version right now. And hopefully I can get a case like that. It's a little bit slim, different profile than what I'm used to, but I think we could figure something out. And right now I'm showing you the original board design from the magazine. So yes, I know the magazine was scanned in electronically, so I'm sure some of the resolution got lost. But this is what I have to do. So I take that, I cut it out electronically, I paste it into a photo editing program called GIMP, and then there are some functions, tools that, you can sharpen, change the contrast to make it look better, but there's always work needed. And in a second here, like right now, I'm going to show you the updated version of what I enhanced the original version. It took a long time, I got to be honest with you. It looks very simple, but I probably put about, I'm going to say 3 hours maybe into this, and that's what I ended up with. So this should be sufficient for a good solid traces on the board. So let's look at the schematic. All right, so as far as the schematic goes, I'm not going to go through it because I'm going to learn a lot more after the project's done, and I can scope it out and see what the heck is going on. I mean, I've got a good idea of what's going on, but for those that want to know, this is the block diagram that I'm showing you right now. And this is the main board schematic. So that's where the business end is pretty much done. And this is the display driver. So we use that CMOS, what is it, the 40110. It's the Swiss Army knife chip for 7-segment displays. It's a wonderful thing. And finally, I'm showing you the timing signals, what we should get from, the low frequency clock and the 555, etc. So hopefully I'll get these, and that's where I'm going to probably learn my best, right? I can put at least, I've got 2 channels on my scope, so I can at least put 2 of those signals up on my scope and then understand it a little bit better. So that's what I'm going to do. So let's move on to the actual board collection of parts. All right, so I've gathered all the parts and I have them all, which is great. Of course, I had to buy some of them. In fact, anything new here I probably bought. But, every time you buy a chip or whatever, resistor, you buy a whole bunch of them, right? So you can use them for the next project. But anyway, I've accumulated a lot, let me tell you. So I've got all the parts, which is great. And by the way, it's battery operated too, which is really good. What else can I say? So here's the board again. It's mirrored and it's printed out. This is regular paper. This is nothing special. What I think I'm going, before I get into the paper type, when you're making these things, you will get usually the full size in the magazine. So just measure it out. And then you'll be in the ballpark at least anyway in terms of your size in your photo editing program. So in the photo editing program, you can scale and then you can set the either the vertical or the horizontal to the correct values, and it'll be pretty close. But you always want to double check, right? So what I do is I print it out on normal paper, and then I'll get a socket or a chip, and I'll just make sure that everything lines up. And if that lines up, you pretty much have it scaled properly. So I'm going to try something a little different this time around with regards to the board. I'm going to use this hammer mill premium laser gloss paper. So I know Mr. Carlson, he used to use this. I don't know if he still does, but he gets great results. But from my experience, I've got 3 different methods or papers that I could use. The hammer mill and the Staples glossy, and then I've got that blue toner transfer paper, which is excellent. That's the cream of the crop. But this time I'm going to try the hammer mill once again. In fact, I think it's on YouTube. I did a video with all 3 of them. So I made a little board. I put a little section of that same board on one board, and I etched it out. And this was the worst, but it wasn't bad, but it wasn't great. But I'm going to try one more time with this. I've got a different laser printer. It's a Brother, and I can change the contrast or the DPI to 1200, whereas my HP printer only did 600. So I want to see if this actually makes a difference, this paper. It'll be a fun experiment. So that's what I'm going to do. Okay, let me get the board printed out on this paper, and then I'll bring you back, and I'll probably do kind of a sped up version, and we'll see how. Okay, so I put the board through the laminator. I screwed up. I lost the video. In any event, you could see it's went through. So this is the hammer mill paper, and it should come off pretty easy. So it's going to absorb the paper, and theoretically it should float right off. And like I said, I've done a lot of these boards, but the traces were never as good. But anyway, maybe we'll have better luck this time, right? It's always good to experiment. You don't want to get stuck in a routine. Okay, so, well, get that out. All right, so now we've got the board. The paper comes off really easy, which I love about the hammer mill paper, but unfortunately it doesn't etch very good, but you never know, might get lucky. All right, so there is the board. It looks pretty good, to be honest with you. All right, let me put you on pause, and we'll put this thing into tank. All right, so the board is etched, and not bad. I really can't complain. Yes, I see some really bad spots right here, but I can get through that. I can fix that. And a couple of bad spots here. Oh, that trace is not even used, so that's even better. Yeah, this seems to be the worst area here, but everything else checks good. I kind of buzzed about 10 traces, and they were all good. I think one of the saving graces is that this board is a good, high-quality board. I mean, you can hear, like when I go over the traces, you could hear how thick they are. With that cheap Chinese stuff from Amazon, you don't get the same, thickness of the copper. But anyway, that's gonna be great. All right, I think we're ready to go. So the hammer mill paper was okay. I set my printer to 1200 DPI, and yeah, put it in the tank, and it seemed to have worked. So let's move on to the actual drilling. So I'll get the holes drilled, and then I'll do a time lapse of the component placement. For new viewers, the drill setup that I have is as follows. It's a Dremel drill with a very, very fine drill bit and a drill press, right? It's that simple. Anyway, what I do is I put the PCB on a wooden board. It just helps, moving it around and such. And also safety equipment. Don't forget that. That's very, very important. And what I do, I've got a cataract, so I got to get that fixed. But what I do is I put my chair all the way down as low as it'll go, so that my face is right in the middle here, so I can see what's going on. And I've got a little flashlight here I know it's not making a difference, but there is a flashlight attached to the drill press to give me a little bit more light. So that's the setup. All right, folks, so as you can see, the board is done, and I did actually turn it on just a few minutes ago, and it does work, so I'm really happy. In any event, the next step is to actually calibrate it, and to do that, what one has to do is short out these two leads here. So that there is a capacitor, and it's supposed to be like a 1%, 4.7 nanofarad capacitor. So I don't have a 1%, but I had a bunch of 5% capacitors. And I found the one that was closest to 4.7 nanofarads through a store-bought capacitance meter. So that's the one I'm using as my reference. And when I turn it on, I'm reading 4.68.74. Anyway, it's in the range. So I already calibrated it before I started this clip. So we're golden. So let me just put you on pause and let me read the calibration instructions further and get back to you. All right, so it turns out there are no more calibration adjustments, right? I'm just that one trim pot and that was it. So I decided to put the cap meter on the bench. As you can see, I've got it right here, and I wanted to go through some of the signals like I'd mentioned in the beginning of the of this video. So I did that, and in fact right now I'm on the low frequency oscillator, and I'm getting about 12.5 hertz, and you can actually see that here on the frequency counter that I built last week, and that's working great. And the other oscillator, the clock, actually is only going at 1 hertz. Now, I must be reading something incorrectly, because according to the timing, I know it's very difficult to see, the clock at the bottom should be a lot more, but it's only coming in at about 1 hertz. So not too sure what's going on, but I do know that the counter is working, so that's the best part. And I did go through some of the other clock pulses too, the reset, the trigger, the latch, etc. And of course they're all making it because the circuit's working, but it was just good to go through it, just to understand it, and I'm glad I did that. So I'm happy with the actual operation of it. I've got a 100 nanofarad cap on it right now. And there is a slight problem. You'll notice that this digit doesn't always light up. I know it's very difficult to see right now. When I put it in a box, I'll show you a little bit later. But, you know, just the bottom LED is kind of shining. The other one is a little bit dim. But I know the 7-segment display is good because, you know, I can see other digits go light up. So I know it's not a problem with the actual LED 7-segment display. Anyway, I'm going on long. Let me get this thing in a case, and then we'll go through a quick final test, and that'll be it. All right, so I've got the case cover on, and it is done, and it still works, which is fantastic. So I'm very happy about that. Just a couple pointers before we test. The power on is to the left, power off, and that's an over range button. So if I've got a higher capacitor, but I'm on a lower range, that'll flash. So that's kind of handy. And there's our ranges, 0 to 9.99 nanofarads, and then 0 to 99.9 nanofarads. And then the center position is 0 to 999 nanofarads. And the fourth one is 0 to 9.9 microfarads. Yeah, it says microfarads. And then the last one is 0 to 100 or 99.9 microfarads. All right, and then of course I've got the scale here. So what I'm going to do is I've got a set of capacitors that I measured the capacitance on a store-bought meter. So, you know, I bought this meter ages ago. I probably paid about $300 or $400 for it. And I've got those values already written down. So let me get that set up and then we'll go through the testing of the capacitors. Okay, so I'm going to whiz through these very, very quickly. So I'm starting off with, well, here's my list. First of all, 200, 400, blah, 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 blah. And that's what I measured on my store-bought meter. Okay, so for the first one, I'm on a 200 picofarad. And this capacitance meter is not that great when it comes to the low range. And, okay, we'll talk about the higher range later. But so the store-bought meter read 201 picofarad, and I'm reading on my meter 180 picofarads. That's what the scale reading is right now. So it's 180 picofarad. Not bad. Let's go on to another one. Okay, just before we go on to the actual list, I got a really low capacitor, and it's an 82 picofarad. And as you can see, this is kind of reading 5 or 50 or 60 picofarad. So it's not that great. Anyway, let's get back onto our list. Okay, I've got the 400 picofarad capacitor on, and we're reading 380 picofarad. Let's go on to another one. Okay, so now I've got a 47 nanofarad capacitor on it, and my store-bought meter read 49.2 nanofarads, and my new Maplin capacitance meter is reading 49.7 nanofarads. Pretty close. Okay, so now we're on the 100 nanofarad capacitor, and my store-bought meter measured 97.3, and my newest meter is reading 98.2. Not too bad. I'm on the next capacitor, which is a 680 nanofarad or 0.68 microfarad, and I just wanted to show you the overrange function on this meter. So let me just move it up a little bit. That should probably do. And let's go over to the meter itself. Okay, so we're reading about 702 on my new meter here. And on my store-bought meter, I measured 697 nanofarad. Not too bad. All right, so now I've got a 3.3 microfarad capacitor on the new capacitance meter, and I'm reading 3.09 microfarads. Hey, that sounds close. And in fact, my store-bought meter read 3.03 microfarad. I like that. Okay, so now I've got a 22 microfarad capacitor on the new capacitance meter. And this is where it doesn't read or measure very accurately, unfortunately. So I'm probably good up to about 10 microfarads, I think, on this meter. Yeah, the accuracy goes down. In fact, it goes down on the low picofarad range and also on the high microfarad range. It's unfortunate, but come on, this is a magazine project, right? So anyway, this 22 microfarad capacitor is reading 15 on my meter, and on my store-bought meter, it's 19.7. So yeah, there is a big difference there, but I just wanted to show you. All right, so I'm on a more higher capacitance, and it's 68 microfarad, and my new meter reads 46.4, and on my store-bought meter I read 66.9 microfarad. So again, there's a big difference, right? So I'm thinking this is good between, you know, maybe 200 picofarads up to about 10 microfarads, this test set. And so what more can I say? Anyway, let's move on to something else. All right, so in fact, there's nothing else to say. I thought maybe I could do some other testing, but we're done. Anyway, look, I'm really happy I built this project from Maplin magazine. I never heard of them, like I said in the beginning. It's probably because they're a UK magazine and I'm in Canada, so I never heard of it. But I do have a lot of their issues. They're freely available on World Radio History. I'll leave a link in the text or the actual comment section for anybody that's interested in looking at some of the projects from the past. Again, I really enjoyed it, and the skill level I'm finding on Maplin is intermediary. So it's probably just, you know, perfectly for my range, and I'm happy with it. Great piece of test equipment. I'll definitely have it on the bench, and I'll use it in some future projects where I need to measure the capacitance. and show you while I'm doing that. So thanks again for watching. I really, really appreciate it. I got a great one for next week, so hang on. More projects to come, and thanks for watching. Bye for now.